everyone! In this video, we will solve some problems of total hydrostatic force on surfaces. Vertical rectangular gate is 8 feet wide and 10 feet long and weighs 6,000 pounds. The gate slides in a vertical slats in the side of a reservoir containing water. The coefficient of friction between the slats and the gate is 0.03. Determine the minimum vertical force required to lift the gate when the water level is 4 feet above the top edge of the gate. So first, let's identify the given in our problem. So we have here 8 feet as the height of our gate, and we have here 10 feet as the base of our gate, and then we have here 6,000 pounds as the weight of our gate, and we have here 0.03 as our coefficient of friction, and we have here 4 feet as our height of the water above the top of our edge of the gate, and we will let this as our height 1. So in the problem, we are asked to find the minimum vertical force required to lift the gate when the water level is 4 feet above the top edge of our gate. So based on our diagram, we have here the force of the water applied on the gate, and it is unknown. So in order to find the minimum vertical force required to lift the gate, we need to find first the force of the water applied on our gate. And the formula in finding its force is equal to gamma times height times area, wherein gamma is the specific weight of our water, and it is set in English unit since the unit in our problem is in English. And h, which is the height from the surface of the fluid to the center of the submerged body. And A is the area of our gate. So plugging in the given values into our equation, we will now have 62.4 pound per feet cube, which is the specific weight of our water, multiplied by 4 feet, which is the height of our water from the top edge of the gate, plus the centroid of our rectangular gate, which is the height over 2 or the 8 feet over 2, multiplied by the area of our rectangular gate, which is base times height, and now we will have 10 feet times 8 feet. So plugging this in calculator, we will now have the force of water applied on the gate, which is 39,936 pounds. Since we have now the force of the water applied on the gate, we can now find the minimum vertical force required to lift the gate. So we will use this formula. Force is equals to mu, wherein this is the coefficient friction multiplied by the force applied by the water plus the weight of the gate. Plugging the values into our formula, we have now 0.03 multiplied by 39,936 pounds plus 6,000 pounds as the weight of our gate. So plugging this in calculator, this will result to 7,198.08 pounds. So it means the minimum force required to lift the gate is 7,198.08 pounds.